Allow me to start. My name is Anwar Battihi. I will be chairing this session. I would like to thank the organizers of this conference for the conference, its arrangement, its topics, and for inviting me to be part of the conference. There are lots of things in my mind to talk about in terms about climate change and water effect and the effects on water availability and water management and water problems and in the Arab world and in the world as a whole. And our friends have been talking since yesterday about mostly about the problems of climate change on water availability as a whole and in the region and in the Emirates and Abu Dhabi. And I have learned many things since yesterday. I hope this final session will teach us more things, and we have 3 people that will talk about their experience. Our first speaker is Dr. Ahmed Assaf. He is the chair of the Department of Civil and Infrastructure Engineering at the American University of Ras Al Khaimah. Hamid is the chair of the Department of Civil Engineering and Infrastructure Engineering. He received his PhD in water resources at the Department of Civil Engineering, of course, from British Columbia, Canada, in 1991, which is an excellent university. I visited it, and I know that I wanted to live there forever. It's a top university. His research focuses on issues of sustainability and water resources management with emphasis on climate change adaptation. He participated in several international and regional water resources and climate change initiatives involving several international organizations, including the Economic and Social Commission for Western Asia, the World Bank, the World Meteorological Organization, and the United Nations Development Program. Prior to joining AURAK, Dr. Assaf was a visiting professor at the American University of Sharjah and an assistant professor at the American University of Beirut, my alma mater, where I got my bachelor's and my master's degrees. Before this, he was a senior water and risk analysis engineer at BC Hydro Corporation in Canada. I don't want to say any more. He has had a good experience to talk to us about the subject, and according to the organizers, I will give you 20 minutes from this second.
Well, thank you very much for a really very nice introduction. I'd also like to thank the Emirates Center for Strategic Studies. It is really a great opportunity for me to be here in Abu Dhabi. Okay, so I'm going to be within the 20 minutes. Okay, I'd like to start first that many people already talked about some of the topics I'll be covering. So what I'm going to do, I'm going to be quick and actually just basically skipping through some of these slides, which actually you have seen already. And we can have some more time for discussion. My focus is really, all of us talked about water security and climate change, but the focus here would be on the Arab region, on the Arab world, and looking at what's going to happen, or what we project to happen, and what could be done about it. The outline, I'm going to actually discuss what water security is. No one actually did mention it. What does this mean? We're going to talk about stresses of water security and how climate change is going to impact that, specifically for the Arab region, and about ways to enhance water security in the Arab region. So to start, actually, water security was not a bad, or water insecurity, I would say, was not a bad thing in this region because it drove people to do innovations. They were looking for water. They built many infrastructure and also methods to contain and use water. We have examples of that. Many of them are still there with us. Dams, aqueducts, afflage, And all these methods are still, we see them, the remnants, really example what people were doing in the past to deal with issues of water. But still, now these days we are facing even a more difficult problem in the Arab region. I thought maybe it's a good idea to talk about what water security is. Actually, water security term as exists right now only appeared in the 1990s and only very scantily at that time. Just recently, within, let's say, last 10 years, it started to appear more frequently. And it has been used by different authorities and different authors to mean different things. For example, things related to security of water supply systems, things related to food security, flood protection, geopolitical tension, and also ecosystem protection, to mention some. And really what that does, it doesn't mean that's a bad thing. These things really reflects different priorities. When people look at the issue, they're focusing on certain issues, and water security comes as a way to really bring their efforts together. If you look at the stressors of water security in the Arab region, there are many of them here, and what I'm going to do, I'm going to go through them. As I mentioned before, some has been already mentioned. They're there here, but I'm going to go over each one of them. Climate change will impact some of these, actually not all of them, in a negative way most of the time, and we're going to see how this is, what that means. First, the region is already, many people talk about scarcity, but it is also another issue. Variability is a big issue here. We have a huge variability in the region. Here an example of the ratio between precipitation and evapotranspiration rates, which tells you that this region is very water scarce. Variability, there's a plot here, without getting into details. If you look at the upper left corner, that's the place where countries have low precipitation and high variability. The Arab countries really sit there in that corner. And that tells us that we are really in a very bad spot here. Demand is very high and is growing, not only because there are more people, but because people actually have a better living standards. They want to take more showers, they like better food and all that. Therefore, they end up consuming more water. And the top line there is actually belongs to the United Arab Emirates. So the numbers are large and growing. The gap between water demand and supply is growing. Someone has actually showed that, similar to it. And we're going to see a gap growing quite substantially, basically related to two things, demographic changes and climate change, which are going to reduce water supply. Another issue here, when we grow food in the Arab region, is not the best place to grow food because we have a very low water productivity because of the high evapotranspiration rates. In addition, that many other practices in the region are not water efficient. We talk about it a lot, but as you go around and you see still people using flooding techniques, they use inefficient methods, and that really tells you why we have a low water productivity. It is an issue. Because of the, all the pressure on the surface water resources or non-existent of these surface water resources, many countries in the Arab region relied on mining strategic aquifers, and many of them are fossil aquifers, which means they're not renewable. And we've seen here the examples in Saudi Arabia that actually they had in the 80s where they used lots of the fossil water to grow wheat and feed for livestock. They have phased that out these days, so therefore this has gone. There's issues in Jordan, there's issues in Morocco, as we see here the examples, where farmers start to really dig deeper and take a lot of water, and the water levels dropped. Salinization of the water followed, and things were not really good. Another issue is high dependency on shared water resources, has been covered also here. The two emphases here, 2/3 of that surface water in the region comes from abroad. And the issue is about what they call it, whoever really on the upstream, is it a strong country or a weak country? Turkey is a powerful country, and actually they are dictating what happens on the Euphrates and Tigris. It's unfortunate for Syria and Iraq. The situation in the Nile is slightly different, but still Ethiopia is actually pursuing a very aggressive policy itself to build dams, and that's also creating a lot of problems. We have extensive water pollution everywhere, and one example is there is a canal, they call it the canal of the Bahr al-Bakr, they call it, and that water takes really sewage directly from Cairo and dump it into one of those fresh lakes, and causing lots of problems. Similar thing happens in Lebanon, so we have major water pollution problems. Governance is not strong, weak, because that's overlapping. There is no, what they call it, enforcement of the laws. They're not very strong here. And we have tend to have what we call centralized system. Now, this particular one is actually talk about another aspect of water security, which is flooding. We didn't mention it here before. What I'd like to mention, since there's the time here, is that the Arab region has the loss of urbanization happening. Many people are moving to coastal areas and areas which actually is like floodplains. An example in Jeddah, the reason why we had, if people are aware of that flood, it killed 150 people. It not only because the storm was unprecedented, but because there was not enough drainage, and also people were not aware of this risk. Many people get killed, and therefore it's a combination between what will happen to the climate, in addition to people not being prepared for these things. Deficiency of information, I'm not going to mention, add to this. The Arab region is deficient data, deficient research and development. We tend to really import research and development. We have weak scientific base here in the region. Okay, so again, this has been said already, but only thing I add to it is that the climate change is going to make the area more drier and more variable. Variability is as important as being dry. And this is an ensemble from different climate models. What's interesting about this actually shot is that if you look at it, if you look at the red color there, that means that precipitation has dropped close to 25%. Not only this, the dots means that most models agree on that direction. So there is a high certainty, to some extent, that the Arab region, which is actually right there, most of the Arab region, not all of it, is going to undergo desiccation due to drying. The interesting part about, since we are here in United Arab Emirates, if you look at the United Arab Emirates, that region sits in a transition zone. So there is actually, models are not sure about what's going to happen there. It could be more, it could be less. We're basically in the transition zone. In the Nile Basin, where Egypt gets most of its water, things could be actually more water. But so the climate change is not necessarily always negative in that sense. How climate change will affect these things? Obviously, some of them are clear. I mean, it will intensify water scarcity. It will make water manager job very hard because you have to deal with more variability. This is very hard for water managers. It will be also, irrigation requirements will be more, higher evapotranspiration rates. Flooding risk will increase because most models project that there will be increase in the frequency of the flooding. And the one before the bottom, the competition over shared water resources. As an adaptation, upstream countries will, as an adaptation to climate change, they will actually try to contain more water and possibly divert that to other places, like in Turkey. Turkey is actually, I was in Turkey a couple of weeks ago, and they're talking about increasing their production for agricultural production from about just about over 10 billion to over 100 billion within the next 10, 15 years. So and most of this is going to happen from areas in the Euphrates and Tigris. So we're talking about here things that will impact the area negatively. And obviously, we need more data. Okay, what can be done about it? Many of these has been discussed already, but I'll just emphasize things which hasn't been discussed. One thing is that when you think about the problems, we need to remember Arab countries are not the same. They differ in their socio-economic development. They differ in their actually climatological conditions. Some are drier than the others. Some depend on water coming from abroad. Others totally don't have any surface water. And geopolitical conditions are different. Morocco, for example, doesn't have any problem with neighboring countries in terms of water because most of their rivers are contained within their boundaries. So they differ really, and when people set strategies, you need to think about that per country. I mean, most of these things are done at the national level. So when we think about it, here, I'll go over some of the ideas. One thing which is important is integrating policies on water, agricultural policies, food security, especially food security, environment, development, for example, tourism development in areas which doesn't have water. So we need to think about that because you cannot think about not having water and at the same time you want to expand your agriculture or to build, let's say, in the desert where you don't have water really to get it to the people. So we need to really talk to each other in terms, even within the same country here. Agriculture sector, and some of this has been discussed, water pricing is very important, extremely important, and helping farmers. You need to develop the capacity of the farmers through extension services, tell them what to do because some of them are not really educated. And another thing here is one of the issues about using water is energy prices. Energy prices, because it is most of the countries you use electric or diesel pumps to pump water. And therefore, if you subsidize energy, you end up actually extracting more water. So this is something we need to look at. Another aspect which is interesting is this one here, is talk about the negative impact of water use efficiency. If you really become highly efficient in one place, you basically reduce the amount of water going down that you were wasting before. So therefore, indirect users and also downstream users are going to have less water. So we need to think about that. This is a very important issue here. One thing here I didn't mention at the bottom is that some of the reason why many Arab countries are very resistant to water pricing is that because in countries like Syria, Iraq, Egypt, they have large populations which are dependent on agriculture. And agriculture for them is not just food production, it is their life. Therefore, making the water more expensive will make life harder for them. So we need to think about that, basically decoupling the development from water pricing and energy pricing, and try in a way really to directly help them, not necessarily through subsidization of water and energy pricing. Enhancing security of domestic water supplies. I'll give a couple of examples here. One thing is in Abu Dhabi, and I think some people mentioned that the GIZ, or I keep making a mistake here, GIZ or GTZ, they actually have an agreement with Abu Dhabi for over the last maybe 15 years, where they're monitoring groundwater. The reason they wanted to establish reservoirs, strategic reservoirs, where they can actually store desalinated water. So water will be stored in top of saline water, so that they can provide about 6 months to 1 year storage of water, because the storage right now in the Gulf countries is around 2 to 7 days. And that's a big issue. It hasn't been mentioned here. There's one of the top water security issues in the Gulf is a storage problem, for GCC countries. In addition that, also you need to think about, I didn't mention this, redundancy. In other words, having your desalination plants in different places. In United Arab Emirates, now there is a movement to build some desalination on the Gulf of Oman, so that people can actually have a reliable source if the desalination plants on the Gulf has been affected for some reason. In addition, we need to think about reducing network losses and that. Protection of water resources, also mentioned today by a couple of the speakers. Here, what we need to think about is that wastewater is a resource. And the reason it is actually quite important because it is available even during the summer. It's available during drought times. Therefore, it is extremely valuable, and we should treat it as such, treat it and reuse it. And it's not about just policies, actually. It is about enforcing policies. Many times you get the policy, but you have no enforcement. Jordan did a good job there. I put an example in Jordan. They have what they call environmental police, actually a real police, that can apprehend people who are actually violating the laws, the environmental laws. We need something like this in many different Arab countries. We need to, in terms of shared water resources, we need to increase cooperation. There are some efforts being done, like the Nile Basin Initiative, although it is not successful. There is work by ESQA to try to come with data, providing data on shared water resources, because people want to know what they're sharing, actually. One of the reasons the difficulty, we don't really know what we share, especially groundwater. We need to strengthen water governance. We keep talking about that, but one of the things that has been recommended is in water services is to privatize water services and keep regulation within the hands of the government. And Abu Dhabi actually has an example here, have a good example. They have a body called the Regulation and Supervision Bureau, RSB. They are independent. They really foresee or regulate the sector on the water, wastewater, and electricity in the country. This is an extremely good example. We need to invest in information system and monitoring. This has been mentioned today. Monitoring is very important. We lack that in the Middle East here. And it has to be done for a long time. When I think there was a question about if you can really observe climate change within 30 years. You cannot, actually. You cannot observe it within 30 years. You observe probably variability more than climate change. So we need to establish these and actually start to build a good database, data monitoring system in the region. ICBA has been done some work, actually, which hasn't been mentioned today. They have a project called Mawarid, where they are in cooperation with the USAID and NASA. What that is, NASA has a way to measure groundwater resources in the region through satellites. And so the idea is to provide that data to Arab countries. Okay, so I'm done now. I just want to say, it's just to wrap it up. What is really the thing about all this is that, as I said, the Arab countries are not the same. When you really set strategies to deal with water security or climate change, you need to think about all these things together. And you can see some countries are trying. I mean, Jordan is trying, United Arab Emirates is trying, and you can see examples. I haven't mentioned them here, but in Jordan, for example, there's emphasis on water demand management, wastewater reuse. Tunis has set good examples. So there are some successful examples, but we need to actually kind of expand those and learn from them. All right, I'll leave the rest for any discussions. So I really end my presentation now. Okay, thanks.
Thank you, Dr. Assaf. We will have the discussions at the end of the session. Thank you. Our second speaker is Dr. Theodore Mallis. He has a PhD in geosciences and hydrology from the University of Arizona. He is currently Integrated Sciences and Deputy Chief Programs at Grand Canyon Monitoring and Research Center of U.S. Geological Survey located in Flagstaff, Arizona, USA. His special interests are adaptive management of Colorado River below Glen Canyon Dam, Glen Canyon Dam use of large-scale flow experiments to inform resource managers since 1990. His recent publications is Global Synthesis of Information related to how flow experiments have helped inform management of freshwater ecosystems and frontiers in ecology and environment in 2014. He has done high flow experiments in the United States Geological Survey Circular 1366. Dr. Theodore Mallis, you have 20 minutes. Please go ahead.
Thank you very much. It's really an honor and a pleasure to be invited to speak to you here today, and I'd like to thank our hosts from the center as well as University of Maine for making this possible for me. And the first thing I want to do, of course, after that nice introduction, is show you a picture of my backyard. And this is basically where we work in Grand Canyon National Park, about 8,000 or so miles from here. And so what I want to do is give you a little bit of a case study history of the progress that we're making in this adaptive management effort on the Colorado River in Grand Canyon National Park, below one of the largest dams that we have in the United States, the Glen Canyon Dam. And with the backdrop of climate change affecting the hydrology within this significant drainage basin in the western U.S. So just a brief outline here, a little bit of the geographic setting for the Colorado River, its development with respect to 20th and 21st century water supply, and also governance in terms of how these ecosystem resources are currently being managed. Dam impacts, operations of the dam, and impacts to the downstream ecosystem, including its reoperation, which happened in the early 1990s, and the implementation of the adaptive management program, which formally started in 1997. Third is the emerging challenges, including the attempt to co-manage the endangered native fish of the Colorado River, which are endemic, meaning that they don't exist in any other drainage basins in the world, and their interactions with introduced exotic fish, which have been introduced over the past century or so. And then finally, an update on the resources of interest, including Colorado River sandbars and the fish responses that we've been measuring in response to a warmer and drier climate affecting the basin. So this is just a brief location slide to give you an idea of where the Colorado River is located in the southwestern part of North America. And this is already one of the most regulated rivers in the world, and it's getting drier, and as our previous speaker mentioned, the variability year to year in the stream flow of this river has actually been increasing, and there's a very interesting article published by my colleague, Dr. Shalene Jain, on this from 2005, if anyone's interested. It's also occurring in what is the fastest growing area in the United States over the past 3 to 4 decades, and this includes California, Arizona, which is the state that I live in, as well as 5 other states in the Southwest that depend on water supply from this drainage. Now, most all of the runoff that supplies up to 40 million people in this basin comes from a relatively small area with perhaps a dozen or 2 dozen ridges at high elevation in the headwaters in the Rocky Mountains. And then, of course, most of the users, of course, are downstream of that. So a critical component of this storage system happens to be 2 very large reservoirs, Lakes Powell and Meade, which are shown here on the left side of the slide. The combined potential storage of these 2 large reservoirs is 68 cubic kilometers, so that's quite a bit of water. And the system was really designed in the 1930s through 1950s to store enough water to meet domestic and agricultural needs for up to 4 years of continuous or repeated drought. And actually, as I'll get into this a little bit more, we've had quite a bit more of a serious drought than that in the past decade or so. Now, the Bureau of Reclamation, which operates the system for water supply, has done a recent supply and demand study, which was concluded in 2012, which actually shows that with projected demands and projected reduction in supply, that sometime in the next 40 to 60 years, there'll be some manner of deficit created here, which really requires some serious consideration. And this is just a larger portrayal of this. You can see basically the projected water supply exceeding the demand exceeding the projected supply in a pretty serious way sometime out in the next 30 to 60 years. And what's really interesting is, even though this sounds like fairly serious and dire news for water supply in the basin, there are actually some ecological consequences that we're seeing in terms of this ecosystem management program, which are a little bit surprising and actually in a positive way. What I'll focus on mostly in the talk here is what I'll refer to as the Colorado River ecosystem, which is a segment of the river about 470 kilometers long between Lakes Powell and Lake Meade below Glen Canyon Dam. And this is primarily the area that runs through the Grand Canyon National Park. For any of you who've ever visited that national park, it's visited by over 3 million people a year and is considered a World Heritage Site. And you can see basically the location of it is centered between these 2 large reservoirs, which are intended to meet the needs of up to 40 million people. Users in California have the largest share of the water. They consume over, well, close to 60% of the annual supply that's delivered downstream. And this is just a comparative photograph. Actually, the one on the left was taken in 1889 by Franklin Nims, and then repeated by one of my colleagues and former boss, Robert Webb, in 1992. And this just gives you an idea of what the setting for the river was like before the construction of the dam historically. And this is the Glen Canyon Dam itself. The facility was built primarily to store water in the upper part of the drainage for delivery to lower basin users. And it's also a hydro-peaking facility, so it's a very valuable hydropower resource for the southwestern U.S. And I'm not sure if you can see at the bottom there, but Lake Powell has also been responsible for retaining up to 94% of the natural sand supply that the river used to transport through Grand Canyon National Park. And filling of the reservoir, which took 17 years actually because of its large size, resulted in a much colder river after about the mid-1970s. And these were significant impacts, as well as the flow operation impacts that occurred after the operation began for hydro peaking power in 1965-66. This is just one example of a Grand Canyon beach within the park that reflects basically the loss of the sand supply that I referred to in the previous slide. You can see the picture on the right, which we matched in 1995 compared to the 1952 photo on the left, which was prior to construction and completion of the dam, and pretty much an elimination of this, this resource along the river, primarily used here for modern boating and camping, recreation. It's also part of the aesthetic landscape of Grand Canyon, supports wildlife and plant vegetation, riparian vegetation also. So sandbar loss has been identified as a problem that resource managers would like to try to mitigate, but again, with 94% of the natural sand supply held up in Lake Powell, it's quite a daunting challenge. And then also, because the flows have been decreased substantially in terms of the annual peaks, the tributary debris flows that still affect the rapid at hundreds of locations along the river below the dam have a tendency to encroach upon the river in terms of navigation, and the rapids that they create become worse and worse through time because of ongoing inputs, as you can see here in the right side match photo from these tributary debris flows and muddy floods that occur. And then also the riparian vegetation, you can see in the modern match on the right, quite a substantial increase in riparian vegetation as a result of the reduced flood frequency, compression of the flood frequency. The scouring floods that used to occur primarily in the spring season no longer really occur anywhere close to what they used to do. So on the left you can see a flow hydrograph from the pre-dam era and the post-dam era, and you can see how substantially the annual spring peaks have been reduced. So we have lower annual peaks now as a consequence of the dam, but we also have higher minimum daily flows. So the daily lows that used to be responsible for allowing a lot of sediment to accumulate along the beaches are gone. Those are higher now, and the annual peaks that used to take the sand that would accumulate in the river and redeposit it along the shorelines have pretty much been eliminated too. On the right, you can see that as Lake Powell elevation increased through time, the natural variability, the seasonal variability in the thermal regime of the river was also substantially compressed too and became a much less variable and colder river. Now, the thermal regime effects are likely the most important for aquatic biological processes. So yesterday, Arya was talking to us about the importance of considering water quality as well as quantity. And I think the story that I'll be telling you here in the next several minutes really holds that up as an example, because a lot of the effects that we've seen ecologically that affect the fishes of the system, we think are primarily due to the thermal regime shift, which was substantial. The pre-dam range of variability went from freezing in the wintertime to up to 27 degrees Celsius in the summer months, and by about 1980 that was compressed down to a range throughout the year of 7 to 9 degrees. So much colder and much less variable. Now, in terms of the governance structure for trying to manage this ecosystem below the dam, in 1997 the Secretary of the Interior, which is one of our cabinet members who's responsible for resources along the river, set up a federal advisory committee which contains 25 separate special interest stakeholder groups who have the ability to attend meetings and provide recommendations to the Secretary's office about ways to improve the management of these resources below the dam. And this is just a slide showing the wide variety of resources at the dam, including hydropower, as well as downstream that I've been referring to, that are of interest to this adaptive management effort in the Grand Canyon. And so the red lines here show where we really have a high level of uncertainty in terms of how the dam's operation affects those resources that are pointed to, whereas the green arrows reflect areas where we've made enough progress, where we think we actually understand the connections and linkages between dam operation and the downstream, for instance, sediment or hydropower effects or water quality effects. And what I'm going to focus on primarily here is the uncertainty that still lingers between the operations of the dam and the native fish, which I'll show you a few pictures of, as well as the introduced rainbow trout, which are shown in the upper right. And these are two fish that, well, the objectives are to get these fish to coexist in harmony in Grand Canyon, in the river. But, of course, one is a native to the system, and the other one was introduced primarily for recreational angling purposes. And then also the nexus that happens when you look at those two species and their interactions with dam operations relative to other flow effects that are intended to really rebuild the sandbars, the sediment resources, as well as affect the downstream water quality. So this is just a subset of the 11 resources shown here, but these several resources in combination and balancing them through dam operations has turned out to be quite a substantial challenge. And really the central focus of discussions, which are referred to in the upper left corner, of what I call value-based trade-offs. You know, we want to have all of these resources together, and at the same time we find that trying to achieve or optimize for one resource can come at the detriment or cost to others. And this is the endangered humpback chub. This is one of the fish in the canyon that's protected under our endangered species law in the United States. And down in the left-hand corner, you can see rainbow trout, which is a common recreational angling fish that's desired throughout our country as well as other parts of the world. And what's really unique about this fish, the humpback chub, is it's not found anywhere else in the world. So it has value in it in the sense that it's part of Grand Canyon's ecosystem, and it's protected under law. So what we saw in the 1980s into the early 2000s was a pretty substantial measurement of the decline in this resource. This fish was basically thought to be heading towards extinction by about 2002, and the estimate was made that there might only be 3,500 of these adult fish left in the entire system, meaning in the entire world in this case. And it wasn't really clear why this decline in this fishery was occurring. The possibilities were the cold water temperature below the dam, the presence of non-native fish as competitors and predators, perhaps lack of food, and one thing that was really pointed to was the fluctuating flows that were associated with the hydropower peaking capacity of the dam might really be the cause of the decline of this fish. And one of the elements to try to manage that, at least in terms of the thermal regime, has to do with how much water is released from the dam and what its travel time is below the dam that affects the downstream temperatures that, of course, affect the fishery. And what you see on the right here, of course, the schematic on the left just shows the influence of solar radiation, sunshine, which can potentially warm the water downstream as it leaves the dam and flows downstream towards where the fish live in Grand Canyon. But the problem is that there are limitations on how low the flows can be from the dam to try to achieve maximum warming or optimal warming to help the fish, because of course there are downstream delivery requirements that have to be met annually to the downstream users. So for instance, in this diagram you can see in the red circle, this is kind of the limited decision space that the managers have to try to manipulate the thermal regime of the river. And the best they could do is perhaps get to maybe 13 degrees of warming downstream. This is based on some modeling that we've done, when in fact what the fish are believed to need is somewhere in the range of 18 to 20 degrees. So there's really not an option for limiting flows to the degree possible or needed to get the downstream warming to help the fish. So it's a bit of a quandary. But one thing that we've seen happen here, of course, in the last decade, and this is where the climate change part of the story comes in, is we've seen basically a pretty dramatic shift in the downstream thermal regime, not because of the operation of the dam, but because of the drying, the reduced hydrology of the upper Colorado River Basin, as it's reflected in storage in Lake Powell. And of course, as storage in Lake Powell gets lower and lower, the hypolimnetic releases, the cold releases from the bottom of the reservoir, slowly transform into epilimnetic releases, which are much warmer near the surface. And so you can see that the wider line at the bottom is the earlier cold average of releases that occurred from about 1990 to 2002. And then the individual traces above that show the individual years of warming that have occurred since 2003 in response to the reduced hydrology and runoff and storage of the upper basin. So this is something that's actually come as somewhat of a mixed surprise to the managers. They really don't like having reduced water supply, but it is achieving the downstream warming to the degree that appears to be helping the native fish to a pretty substantial extent. This plot just shows, basically depicts graphically what's happened over the past 22 or 23 years. And on average, basically there's been about a 2.5 degree centigrade warming that's occurred downstream where these native humpback chub exist. And so this has actually been something that wasn't planned, but it's something that's happened, and we've been monitoring it. The adaptive management program really is founded on the principle of monitoring and trying to learn from that monitoring to improve resource management of the dam. And so what's happened over the course of the last decade or so is the original estimate for this endangered fish, which was about 3,500 individuals in 2002, 2003, increased by 2008 to 7,600 fish, so more than a doubling. And the latest estimate, actually, which was just produced this year, estimates somewhere between 10 and perhaps 16,000 fish. So this is a pretty substantial increase, perhaps a factor of 3 to 4 increase in the adult population of this fish just since 2000, and we think primarily in response to the climate change-induced drying and warming that's occurring in terms of the dam releases. And it's not just that native fish. There actually are several other native fish. They're not listed as protected under ESA, but they've been showing a similar increase too. And you can see the blue arrows for the flannelmouth sucker and the bluehead sucker towards the bottom. They've been increasing too, apparently in response to this shift in the thermal regime, which again is a consequence of the drying that's occurring in the Colorado River. And at the same time that that's been occurring, of course, the introduced rainbow trout, which is shown in the plot on the right, went into a pretty dramatic decline. So trout like colder water, our native fish like warmer water. Nature's provided basically through the drought and climate change story the kind of things that seem to help the native fish and keep the non-native fish at bay. So this is sort of more good news for managers that's been coming up and coming out of our monitoring program, although again it's not something that was anticipated when the program was put in place 20 years ago. In terms of the eroding sandbars, just a few slides here to show that the concept of trying to have these high flow experiments, these controlled floods under certain conditions where there's new sand inputs below the dam that allow bar building to occur, seem to be working. These are basically lines that represent 30 sites that have been monitored since 1990, individual sandbars. And it looks like, for the most part, around the timing of the controlled floods, which are shown here as the peaks in discharge, there is a substantial increase, for a time anyway, in the sandbar volumes. But then over time, they tend to erode under fluctuating flows and then get rebuilt again in the timing of the next controlled flood. And just in the past 2 years, we've gotten through a series of recommendations from the scientists. The Department of Interior has agreed to have these types of floods as frequently as annually. And so the sandbars, as you can see as you move from 2010 to 2014, seem to be at least starting to move in an upward trend. And this is encouraging news because, again, we only have about 6% of the natural sand supply to work with here. So this is also something that seems to be responding positively to the drought because, of course, the flows in between these controlled floods tend to be less in annual years where the flow volumes are reduced, and so the sandbars tend to not erode as quickly and they tend to persist longer. This is just an example here of what the sandbar building looks like after the controlled flood. You can see the results on the right slide after the flood subsides. There's a nice big sandbar that's left there, and again, this is habitat for wildlife as well as human beings for recreation that are valued in the Grand Canyon. So the hydropeaking flows will erode these types of sandbars, but in drier years, under the drought with lower flow volumes, they tend to persist longer. And so now the Department of Interior has actually agreed to conduct this experiment at least through 2020 to see if it's possible to rebuild these sandbars at a faster rate than they get eroded by hydropeaking operations in between. And during the period of minimal flow releases, which we've been experiencing now since 2001, it looks like there's a greater possibility that this resource objective may actually be gaining in a positive and persistent way also. The question is, what would be the future sand supply? Below the dam, we still get, from a couple of tributaries, sand occasionally, sometimes on an annual basis. You can see on the left the annual loads of sand that come in below the dam since about the time it was closed in 1963, highly variable. And then from a recent study that was done by Hirsch and Ryberg, looking at the trends of annual peaks for drainages in the Southwest, it seems like there's a pretty clear trend throughout the region for declining or decreasing annual peaks. And so we're not quite sure exactly what this will lead to because as terms of climate change, the question is, do we have a larger or stationary sand supply in the future? And that'll have a big bearing on whether or not the sandbar objectives can be achieved. And then the combination of the sand inputs as well as the annual releases, which is just briefly shown here, will really have an impact on whether those sandbar resources will be maintained or eroded into the future. And right now we're in a period where we have relatively large sand supply and relatively small volumes released from the dam, so that looks encouraging. If you're interested in these large-scale flow experiments, we've written a report, which I have some copies available for. You're willing to take one home if you're really interested in looking at it. They're also available online. And it'll give you a little more information about what we've been doing in terms of these controlled floods over the past 15 or 20 years. And just in summary here, the take-home messages are, it appears that the native fish have been fairly robust to any change in operations of the dam. They don't really seem to be affected by hydro-peaking at all in a detrimental or positive way. Although the native fish aren't, the non-native rainbow trout seem to be very sensitive to changes in flow operations and tend to actually benefit from some of the same things that the sandbars benefit from. But the humpback chub overall seem to be responding positively over the past decade, primarily to the thermal regime shift and the reduction in non-native fish that's been occurring also at the same time. And the remaining uncertainties in this program right now, again, related to ongoing climate change, is whether or not this increased warming will eventually backfire on the managers, and too much of a good thing may actually lead to proliferation of non-native warm water species, which we also have, and they could be potential threats to the native fish. The non-native rainbow trout, if they can be managed through flow operations or other means to keep their numbers down, that may be something that's required to keep native fish surviving in Grand Canyon. And then, of course, the controlled floods, which benefit the sandbars, which I showed you, also tend to have a positive effect on the rainbow trout population in terms of their ability to reproduce. And so trying to balance within climate change and dam operations, these resources, these native, non-native fish and sandbar resources, has really turned out to be a bit more complicated than I guess any of us ever imagined. But that's kind of the update from Grand Canyon National Park, and just a few scenes to leave you with. And if you ever get a chance to come visit us, I encourage you to do so. Thank you very much.
Thank you, Dr. Theodore, for a practical, direct study that you did. Our speaker is Dr. Shaleen J. He is an associate professor of environmental and water resources engineering at the University of Maine in the US. He also holds cooperating associate professor appointments at the University of Maine School of Policy and International Affairs and Climate Change Institute. Dr. Jane is a graduate of Utah State University and completed postdoctoral work at the University of Colorado's Cooperative Institute for Research in Environmental Sciences. Before arriving at the University of Maine, he was a research scientist at U.S. National Oceanic Atmospheric Administration's Earth System Research Lab in Boulder, Colorado. His areas of expertise include hydrology, climate change, water resources, sustainability, and decision-making under uncertainty. Dr. Jane teaches courses in surface and groundwater hydrology and water resource sustainability. In 2011, U.S. National Science Foundation awarded Dr. Jane its prestigious Career Development Award in the area of environmental sustainability. The floor is yours, Dr. Jane, and you have 19 minutes.
Okay. Very good. Thank you, Professor Batiki, and our host at ECSSR. It's certainly a pleasure and honor, and I've really enjoyed interacting with all the attendees here. So what I'll be focusing on is thinking about water problems and solutions largely in a management and policy context. Now, I'll try to provide, on the one hand, a personal perspective on these problems based on the work that my students and I have been doing, but also urging that we focus on a more holistic approach and find ways to really harmonize, and as we understand the ways in which water affects us. And so this idea of integrating the resource hazard and stewardship perspective is a key one in my research. We have heard several speakers address some aspect of these problems, and I feel like we would really be helped by looking at these in a holistic fashion. And so before I go forward, I want to acknowledge my students who are involved in these projects, and I'll be highlighting who's involved in which project. So thinking about water management and policy, we see from a governance perspective, often we have agencies and organizations that may focus on a single aspect of how water impacts us. So, for instance, from a resource perspective, we are often focused on problems of agriculture, assuring reliable water supplies, building infrastructure as in dams and such to help assure these supplies. From a hazard perspective, we often have issues of floods and droughts and specific agencies addressing those issues. The stewardship perspective is somewhat new, and it deviates a bit from the conventional engineering approaches, and as our previous speaker very articulately helped us understand as to how important these resources are, be it species or supporting environments that in turn offer us ecosystem services as well as aesthetic and cultural assets. So before I go further, I think in my own work, we have actively focused on this idea of usable knowledge, where we acknowledge the fact that the scientific information and research is only a part of the solution, and we actively engage and seek out knowledge from stakeholders, decision and policy makers. So when we solve problems, the uptake of scientific knowledge and solutions is high. The other thing we see often is being really mindful of the fact that a lot of problems related to water ought to and should involve experts from different arenas in sciences as well as social science and policy. So if we think about water problems broadly and then compounded by a variable and changing climate, I have about 3 key, I guess, headers to help us think about how to approach these problems. The first one is that the climate variability and change affords both challenges and opportunities. On the one hand, a lot of these problems are occurring or being reported very often, and the public and the governments are actually willing to invest and help. On the other hand, we also see that looking forward, these problems have extremely large potential impacts on our well-being, which would be economic, social, as well as environmental. So looking at how to understand these problems in the context of large-scale climate variations is, I think, extremely important and urgent. The second is that including human context and stakeholders really is an important aspect. And so as we approach these problems, I think really actively integrating place-based, regional, and global scales, as well as the stakeholders who either are impacted or have local knowledge would be very important. And then finally, as our keynote speaker highlighted and helped us see that these changes in climate and hydrology are probably poorly understood if we just think of them as simple linear trends. These may actually end up as irreversible transitions and involve surprises. And so approaches that take climate, hydrology, ecology, and human dimensions are urgently needed, and so are the interlinkages between different sectors. The interlinkages between water, energy, and food are probably a important example, and then finally focusing on how the governance of our water resources is done is a really important aspect as well. And so in this schematic, what we are really seeing are conceptually the way in which climate influences hydrology as well as our ecosystems. And then we have constructed facilities at the bottom left where we do water resources management, and on the right side, increasingly in a lot of areas of the world, we have either standards or policy to assure the health of ecosystem, especially where we have altered hydrology. And as we saw earlier, adaptive management offers a useful approach. So where is Earth's water? This is from the USGS, and we see that a lot of our resources are in fresh water lakes, and then about 30% of the surface and other fresh water is groundwater, which has longer replenishment time scales. So what I'll do is I'll talk about a few examples from our research that actually takes the step to address salient problems, yet acknowledges the key principles I have highlighted here. And a lot of this is work in progress, and so I'll be happy to give updates if you're interested later. And so the first project I've been involved in focuses on culverts. As you see at the bottom left, these are systems that during and after a rainstorm carry the storm runoff safely, and in cases where they actually fail, you can see in the picture on top, you have substantial impacts. And so one of the problems in coastal Maine we have been focusing on is the incidence of more frequent extreme storms, and we wanted to help address those problems. And so we started out with the way we approach it is we have done upfront engagement and scoping of these problems with city officials through questionnaires, interviews, workshops, and focus groups. And from it and our own understanding of changes in regional hydrology, we arrived at our research needs. And one of the key question was a reappraisal or thinking about how to approach the sizing of culverts if we have changing statistics of extreme rainfall. How would those be included in the design and sizing of culverts? We also wanted to really understand that in an annual cycle, what are the maintenance calendars for these culverts, and if the seasonality in rainfall extremes has been changing, should this calendar also be updated? And then, since all these pieces of infrastructure involve financing and a range of maintenance and other concern, another question our stakeholders pointed out is that they just do not understand how these things are governed, and so we wanted to map governance. My colleague Esperanza Stanshoff was actively involved in our outreach and engagement research, and so was a former student, Alex Gray. And so here's an example of what's going on, and it's a bit complicated and overwhelming. So what we are showing here is how we approach this project. And so if you see this circle on the left, we started out with initial scoping, data coast-wide survey, and then did what we call survey with folks elsewhere, where we asked that, is our survey robust and useful that it could be applied elsewhere? And then from that survey, we got a much more focused problem specification, and from it, as we started to think about governance and financing, we figured out a range of state and other agencies who are involved in this. And then from a design perspective, we found that there are at least 3 agencies who have very specific rules for how to design these culverts. So our modeling and decision tools have been informed by this work. And then on top, if you see, is the scientific work involving hydrology, past and future climate, and such to include those factors in our solution. So this is an example of the scale and scope of solving these problems in a lot more of a engaged fashion. So here's an example of the culvert governance map, and we followed up and did some estimates of how the extreme rainfall has changed over time, and then how to use this updated information for the sizing of future culverts. We also identified changes in seasonality of extreme rainfall, and what this picture is showing is that there's actually a emergence of spring season extreme rainfall, which has happened in the past couple of decades. And so instead of doing maintenance in the summer, these agencies should be doing maintenance in spring so that the culverts are functioning properly during the spring storm. So these are small yet tangible examples of when we address these problems, we increase the likelihood that our stakeholders would actually take these solutions and act on those. And so this work was acknowledged and was actually featured as a key example of adaptation approaches in the United States. Now, since I'm short on time, as I expected, I'll go even faster. Okay, so my next example is our approach to understand the role of climate on lake iceout and its implications for water quality. And in Maine, we have been trying to understand, with a warmer and variable climate, what are the impacts of early ice out on the lake water quality. So here's an example of how this system can be expressed as a tentative model. And what we have been able to do is to understand what are the oceanic and atmospheric features that are actually causing early ice out in our state. And we have actually extended that and actually shown that lakes in North America and Europe and Asia also shows similar patterns and are influenced by changes in the tropical Pacific Ocean. I'll largely skip over these examples where we have gone about in a systematic fashion, linking climate variations with impacts on stream flow and ecosystems within the streams. And this is a case study from the Korean region. Furthermore, what we have also done, here's an example from the Western US, and we have actually looked at the changes in the seasonality of stream flow and then provided very focused linkages of those changes to both the water resources management, as well as the impacts on fish and ecosystems. So, and finally, what we see in solving water resources problems is this approach called IWRM that is extremely popular. However, we wanted to step back and really appraise this popular approach. So we have a tentative framework to understand this approach being applied around the world. And Lozier, who's a student in my group, has actually gone and gone over hundreds of case studies and actually summarize and assess the strengths and weaknesses of this approach, and then is proposing a water resources stewardship framework that further expands IWRM and actively integrates the environmental flow and ecosystem services as a key objective, alongside factors such as equity, engagement, and so on. So this is my final slide, and in some ways this speaks to some of the things we have learned at this conference. So one aspect is to really understand emerging and salient problems and actively allow a scientific research program to address those problems. So the idea of scientific knowledge as a key ingredient in solutions. The second is that these systems are often extremely complex, and these responses aren't simply linear, and so acknowledging those features and actively looking for those features in these problems. The third is the fact that water problems are occurring at all scales, and so including cross-scale linkages is extremely important. The final 2 points acknowledge the fact that we have tremendous insights individually, and it'll be really useful to work in a collaborative fashion to address these problems. And then finally, this idea of adaptive management and learning within a research, resources, hazard, and stewardship framework is, I think it's a very promising framework to approach these problems in a holistic fashion. And so I'll stop here. Thanks.
Thank you, Dr. Zaid, for the good presentation. Thank you. Let's take 2 questions. If you have any questions, yes, Dr. Saleh.
Thank you. Before I ask the question, I would like to thank the organizers and all the speakers for such a very informative talk.
Raise your voice, please.
I said just I would like to thank the organizers and the speakers for such a very informative 2 days gathering. My question to Dr. Assaf is, you said that Arab countries are not the same, and that's obvious. And I'm referring here to the GCC countries. Do you think that due to conflict of interest, it will be very difficult to reach a common water strategy in the region?
Before anybody leaves, I would like to interfere and let you know that Dr. Swady will give us a word. He is Sanad Swady, the director of the center, and Miss Amal Misafiri, Dr. Amal Misafiri, will say it on his behalf after we finish. So please don't leave and let us listen to the final statement after we finish both questions.
You're referring to GCC countries, right? Yes. I think there is a ground for cooperation. I mean, there are examples of this. One thing is that what you require in the region is you want to improve the reliability of desalination plants. One of the initiatives in the region, which may not actually take place, may or may not, is to build pipeline between GCC countries where desalinated water can be exchanged. These kind of things, I think there's a common ground among the countries to actually develop such schemes. And that will help every country there in this case here. Let's say if you have a problem in one place, the other will pick up. Similar thing is done could be done on the electricity and also transportation. So I think there is a common ground to actually have these kind of initiatives or some collaboration in that sense. I'm not sure if I answered your question, but I think there is a good ground for cooperation, yes.
Any other question, Dr. Murad? Dr. Ahmed?
Thank you.
Yes.
My question is to Tim or Ted, yeah. What is the thickness of the sedimentation that accumulated behind the Grand Canyon Dam or Glen Canyon Dam? Thickness of sediments.
The sediment behind the dam is almost none.
None?
Because the scale of the reservoir is over 200 kilometers long. And so the high sediment loads from the river that still move into the reservoir, they stop at the head of the reservoir, and virtually no sediment makes it through the bottom to the dam because of the length.
Okay, what is the velocity of the... What is the velocity of the water, flowing water, behind that?
Into the reservoir?
Yes.
It's a lake. It's virtually zero.
The velocity?
It's very, very low.
During the flood?
Very low, extremely low. Extremely low.
Yes.
So
But during the flood?
During the controlled flood?
Yes.
5 meters per second.
5 meters per second.
Liters per second.
5 meters per second flow.
Meters, sorry.
But most of the time it's much slower. Yes. But the sedimentation behind the dam is not an issue because all of the sediment is falling out over 150 kilometers upstream of the dam. These are very large reservoirs. And so the only sediment we have is a small tributary below the dam that occasionally adds sediment. And that's what's used for the beach building. But it's 6%.
Any other questions? Is the lady ready for her our chairs and leave the lady?
In the name of Allah, the most compassionate, the most merciful, ladies and gentlemen, I'm pleased at the end of this conference about the climate change and the future of water to extend my gratitude and thanks to you, all of you, researchers, speakers, and attendees, for your effort to prepare for this conference. Thank you for your presentations. Thank you for your serious questions and comments during these 2 days. We shed light on a number of topics and we give a great importance to the climate change and the future of the water in the UAE and GCC in general. I have to thank your extended efforts, especially the University of Maine. We thank you for your cooperation to organize this conference, and I thank in particular Dr. Tim, the Vice Director, and all the other professors for their presentations, which add a value to the topic of future of water. I also thank the representatives of University of Maine for their efforts. I hope that we continue our cooperation in tackling and addressing the strategic and the security issues which are of common interest to us, and this build up on our efforts regionally and internationally. The recommendations that you concluded in this conference will find ears among the decision makers and will help them make the right decision to manage more effectively and in a better way till we achieve the stewardship we are looking for and the good management of the water in the future in the UAE and in the GCC countries in general. And I think that such discussions will help us face the challenges of climate change and the management of future of water in the future. Thank you very much and see you again.